Hi guys, Mr. T again, and still here at my virtual beach, and we're ready for part 3 of graphing more complicated rational functions. Okay, we have talked about already the parent function, which is just this guy here. It's a fraction that has an x in the denominator, and so to avoid having division by zero, there's this vertical asymptote that's kind of a force field that keeps anything from causing division by zero. And then we also noticed their behavior of these horizontal asymptotes, and we came across a couple of reasons for that. Okay, but today we're going to be looking at more like this guy right here. We've already dealt with the two of the three situations from our chart here. Number one was when the degree on the top is smaller. We've dealt with that in part 2. And then when the degrees are equal, we dealt with that. Today, in this video, we're going to deal with the situation on the horizontal asymptote when the degree on the denominator is bigger than the numerator. Okay, so that's our first example we're going to have. Our second example is what happens when my factor in the numerator and denominator cancel, and you get something called a hole. And okay, a point of discontinuity is what they would call that. And then we're going to have a bonus example of what happens when there's no value that would cause the denominator to be zero, even though there's an x in the denominator. What could make that happen? So we're going to look at those three examples here. Okay, some of the more odd features of these more complicated rational graphs. So let's jump on up here to hide that, and talked about that hole there. And then those when the degrees are equal, just get that front number, get your horizontal. And then when the degree on the bottom is bigger, for those two guys. And now we're ready for this guy here. All right. So we recognize that the top, the numerator, the degree is 2, because you would have 1 and 1 makes 2. And then the degree on the bottom is 1, so the degree on the top is bigger. Okay. And so we one thing we can take note of is that we would have a vertical asymptote at x equals -1, because that would cause division by 0. Okay, so I can go ahead and put that right on in there. So that's one thing we know for sure is going to happen at -1. So there we go. So there's our vertical asymptote we know about. But our horizontal asymptote, there's not really a 1. There's going to be a diagonal 1. And how in the world are we going to do that? Well, let me show you how that would work. We're going to do some division. Okay. First of all, let's go ahead and FOIL this out. And so x times x will be x squared. Then you'd have -1x plus 5x would give me 4x. And then 5 times -1 would be -5. Okay, so you can even more readily see the degree is 2 here. So we're going to actually do this division so we can figure out the equation of our slant, our diagonal, our slant asymptote. Now, lucky for us, we have an x plus 1 in the denominator, so we can use synthetic division. If it had an x squared and that was a cube up there, we'd have to do long division. But we can do synthetic division, which is awesome. So we're going to take, if x plus 1 is the factor, we're going to put -1 up here in the corner, and that would be our potential 0. Okay, so that's what goes up here as our divisor. And then we take the coefficient of x squared, which is 1, coefficient of 4x, which is 4, and then the constant is -5. Okay, bring a nice little line out here, put a little box for our remainder, wherever that might be. So do synthetic division. We take our first number and bring it straight down. This helps us get started. And then we're going to multiply, add, always multiplying times -1. So -1 times 1, put our answer over here. That'd be -1. Then add gives me 3. Multiply by -1 again, we get -3. Add, that gives me -8. Okay, Now, for this particular situation, we found out that x plus 1 is not a perfect factor. Well, duh, we see it right here. We just proved it, though. Okay, but we do realize that -1, -8 will be on our graph somewhere. Okay, but at this moment, could care less. Okay, not needed at the moment. Okay, not needed. Could care less at the moment. Okay, not needed. What we're going to do is we're going to say, hey, we're going to take y equals 1x plus 3. That's an equation of a line, isn't it? Okay, so now we're ready. We're going to graph that line. So I'm going to put a couple of dots in here so we can help me get my graph together. So we're going to have a y-intercept of 3, okay, and a slope of 1. So that would land me up here. If I do that slope of 1, see, I think that should be good enough for me to use my line tool now. Yeah, my dotted red line, so that works. There we go. And so, all right, there we go. So now we have our asymptotes, which when we're doing these rationals, that's the first thing. Get your asymptotes in first. And now, what do we do? Plug in the calculator and plot points. How many points? As many as you can get to fit on there. As many as you need to make the picture look right. Okay? So don't be lazy. Just put it in and start doing it. So here we go. I got it. Already got this highlighted here. Whoops, I don't need that 1 in this case. Well, I guess I could. We don't need. That's not going to be necessary. So we'll turn that guy off. So we'll go look at our graph. Okay. So what? Let's go back over here. Let's go back down to this, and let's put in that thing. This it was x plus. Whoops. Try again. X plus 3. Now look at our graph. See how that guy's going straight across there? Okay. And just for grins and giggles, I'm going to show you that -1 line in there as well. And that's a 4. Okay. And so you can see that guy going through there as well. So, and that's nice, but what do we really need? We really need our table. Okay, let's go to the table. And so I have here starting at x equals -12 because I got plenty of room. And now I'm going to start graphing these. Okay. Okay. Got to take this down off the screen, but I'm going to use my handy dandy calculator of my own and just plot points so that we can see what's going on here. Put it on my tool here for a pen. And just start, I'm going to start over here at -10. I may even go up to -12 because I got some room here. So -12, -8. So -12, -8.2. About there. Okay. And then let's drop on down to -10, -6. -6 at -10. It's actually -6.1. So just a hair more. Okay. Then -9, -5. So that's right on it. So we definitely want to do that guy. It's going to take a second. There's quite a few points on this one. -8, -3.8. So right about there. -7, -2.6. So just a little bit over halfway. And then -6, -1.4, 1.4. Then -5, 0. Okay, then -4 up now. We're going up to 1 2/3. Okay, and then -3, 4, all the way up to there. And we'll get one more in here, don't we? -2 and 9, way up here at 9. Okay, and now we play connect the dot. And I'm going to do my best. It's not going to be perfect, but I'm going to give it my best shot to do okay here. Keep on and going. Okay. All right. Not perfect, but that's kind of what we need to do right there. All right. So, but is that it? No, we got a whole nother side to go. So let's keep plotting points. Probably should have kept plotting points instead of quitting. So let's see, -1 error. Well, that's that asymptote. So we okay, all right. And then we go up to 0, -5, 0, -5. Okay. And then 1, 0, 1, 0, 2, 2.3, 2.3, 3, 4, 3 up to 4. Okay, 4, 5.4. Right there. 5, 6.7. 6.7, 6, 7.8, 6, 7 point way up here. It's actually 8 and a little bit. And then 7, 9, 7, 9. Okay, I think we got the idea there, didn't we? Okay, so we're coming through here and doing the best we can with that. Just a little bit more. Those long distance gets a little bit harder. Okay. So, all right, here we go. So this is an example of a slant asymptote. When the degree in the numerator is bigger than the degree in the denominator, you still do your vertical asymptotes, okay, with your -1. Then you do some division. If you can get away with synthetic, that's great. You take your quotient, and that should be a linear. You graph the line. Then what do? Plot points. How many points? A lot of points to it. Looks like it's supposed to. Okay, so that's that example. Now we'll deal with another strange example. Okay, let's jump over here to this next one. Now this one is got the degrees are going to be even. Okay, so when the degrees are even, we take those front pieces we said, and so well, number one, let's just do horizontal first. Horizontal asymptote is going to be, there's 1/1, so it's going to be y equals 1. So that's our horizontal. And then for our vertical asymptote, well, we see that x equals -1 would cause the denominator to be 0, and x equals 1 would also cause the denominator to be 0. So, okay, but there's a strange thing here. X equals 1 is not going to give us a vertical asymptote. See, because these x minus 1's cancel, or reduced to 1, that's going to end up giving us what's called a hole or a point of discontinuity. Okay? So when we go to graph, we're just going to chug along, whatever. But when we get to x equals 1, we're going to put a little open dot 1. Okay? And just kind of skip over that. Because while we have, because of these two canceling each other out, that huge force field vertical asymptote has kind of gone away. But we can't ever forget that it did exist. So that's why the hole will be there. And so if you graph it on a calculator, you're not going to really see it usually. But you have to, when you go to the table, you'll see an error message at that one little spot. Okay. So let's do some horizontal asymptote and vertical asymptote. Get those guys in there. So we said y equals 1 for this guy here. And then -1 for the vertical. And there's nothing really we're going to do for the hole at this point. Now we just got to go in there and do some graphing. So come back over to my calculator. And I need to turn this equation on and see, I think this one was what? Y equals 1. So we can do that for our horizontal. And then you go down here and turn that guy off so we can see what's going on. All right. So that's the kind of the picture we're going to be shooting for. And then remember, we got this vertical asymptote running through right there. Let's go to the table. Okay. And so here we go. We're going to graph those points right along in there. But if you'll notice, when we get to the +1 down here, look what happens. See that? So we got a -1 error because that's the asymptote, right? That's the asymptote. But when we get to +1, we also get an error because that's going to be our hole, okay? As opposed to an asymptote. And then we just plot all those points, okay? So let me get my handheld one. So because I got to close this down so we can do the actual graphing. Okay, ready to go. Got my handheld ready to cooperate. So we're going to start plotting some points. I got, so I'm going, what, -11 is 0.6. So that's close enough. -11, +0.6. That'll work. 12 was pretty close to the same thing. Oh, let's make those blue since our asymptotes are red. Okay. And then I got -10. Nothing says I have to. It's 0.5-ish, 0.5, and then -9 is actually 0.5. And -8 is 0.4. And then -7.3, 0.2. Okay, -5 is 0, actually on the axis there. And -4, -0.3. Then -3, -1. Okay, we're starting to get some serious turning going here. -2, -3. Ooh, really serious turn there. And then you hit the asymptote from there. All right. So come on down this way. Plane connect the dot. And just gotta, oh my goodness gracious. Well, at least I stayed between the two lines. There you go. It's kind of tough because I'm looking at the screen and drawing with my hand, so I'm not actually looking at my hand when I'm doing it. It's with this little device I use. All right, let's get some more points in here. That's what we got to do. It's just plot points, plot points, plot points. Like I keep on telling you, just plot points. 0, 5, then 1. That's an error. Okay, and then 2, 2.3. So 2, 2.3, about there. So it's actually going to cross at the 3 here. That's going to end up being our open dot right there. Did some calculations, and that's what I found out. So 3, but you still can just estimate it by the time, as you're taking this turn. When you connect all these dots, you'll figure it out. Then 4, 1.8, and then 5, 1.7, 6, 1.6, 7, 1.5. Okay, I think we're kind of getting the idea here. Let me jump on out here to 10, all the way out to 10, and it's on 1.3, 1.36, so it's about right there. I think we got the idea. So as we're coming from this side over here, and we're just kind of coming along here, it's just kind of hugging the asymptote, and then it starts making the turn, and it's going to come right up to this point here, jump over it, and keep on going. It's called a point of discontinuity, the actual math term, and we just kind of call it a hole in a graph, which basically says instead of doing a vertical asymptote at x equals 1, because these two guys cancel, we just put a little hole there, and we can't use that. Now we can do 1.0001, we can do that, and we can do 0.9999999. Yeah, but we just can't use x equals exactly 1. Everything else is free game. Okay, so that's our second example where, and in this case, we have a hole in our graph. Okay, now our bonus example is coming up next, and it's very odd. Every single thing that we've done so far has been started off basically with the vertical asymptotes, looking for things that would cause the denominator to be 0. Okay, all right. Can I think of anything I can plug in for x to make this equal to 0? Well, because of it's squared, no matter what I put in there, it's going to be positive, and a positive plus a positive stays positive. It's not even going to be a negative. Okay, so in this case, so no matter what I put in here, it's going to get squared, which turns it to be a positive, plus 3. So a positive number plus 3 won't ever be 0. Can't be 0. So what do you do about that? Well, I tell you one thing I do notice though is the degree on bottom is bigger than the degree on top, and when that happens, what do we say? Our horizontal asymptote is going to be y equals 0. So we can put that in, we just don't have a vertical one. So let's put in our horizontal asymptote, which happens to be our axis. Okay, so there's that guy there. And now, what do you do next? It's all the asymptotes I can do. What? Well, plot points. Simple, guys. Plot the points. Put it into y equals and get that thing done. So let's go back over here, make some adjustments. Whoops, get up here. Let's turn that guy off. Okay, so I can use him later. And I guess we said the horizontal was going to be 0, right? And oops, skipped him. Come back over here and turn this guy on. That's the one we're about to graph. And so let's go take a look at this guy. Wow, that is weird, man. That is so weird. It's so weird. Zoom 6. But you know what? No big deal. All I have to do is go second table and start plugging in points. Well, there's the horizontal, and then start plugging in these points. No big deal. Okay, let me make the same adjustment on my handheld calculator. Here we go. I got my handheld going. Let's go back over to the graph. And now I'm just going to be plotting points. Plotting points. I can plot some points. No big deal. Okay, so negative 12.18. As in like, yeah, barely. Boom, right there. And then I'm going to skip to negative 10. 2.6. I mean, point 0.26. So that's basically around 1/4. And then I'm going to skip to negative 8, which is 0.4, still under half. We'll skip to negative 6 is 0.7. We're getting up a little bit now. Skip to negative 4 at 1.4, 1.4. So, okay, we got a pretty good jump there, didn't we? Okay. And then negative 3 is 2.25, 2.25, right about there. And negative 2 is 3.9, 3.9. Negative 1 is 6.75, 6.75, 6.75 right there. And 0.9. Okay. And I bet you the next one's going to be right there. What you want to bet? Bet you it's symmetric. Sure is. So this guy is symmetric. So now I can just slide over and match it. Okay. Because these guys are symmetric. So I just go one over, then drop down and match the one across the way. Go over and drop down and match the one across the way. Oops, we skipped one. So that's what's going on. I was like, oh, that wasn't matching. There we go. And then we skipped one again. And here we go. All right. So this is what happens when you get something where there's nothing that could make the denominator equal 0. Something along this lines. And we could spend a lot of time talking about what parts do what, but this is the idea. Okay? That's really odd. So there you go. We've had so for this video, we did an example where the degree on the top was bigger. And so we got this slant asymptote after we did some division. And then our second example was what happens when our factors cancel or reduce to one. It removes the asymptote but leaves a hole in the process. And then our third bonus example here was what happens when you got an x in the denominator, but there's nothing you can plug in to make it equal to 0. You get something along this lines. All right. As always, hope that's helpful, and put all this together, and I think you'd be great at graphing rational functions.